Hey guys, what's up? Eddie All here with KissAnalog.com. Today what I want to do is I want to present these power supplies you're going to see on the bench. I'm going to be using these for a lot of audio projects. I've got these two Kaiweets I got for that, and I like them a lot. I've reduced the noise in one of them. I've done a video on that. I'm going to do another way on the second one and see which one works better. But these are supposed to be low noise power supplies. They also, the Kaiweets these go around 31, 32 volts, 10 amps. These are 60 volts, 9 amps. So I love that voltage range. And I just found them by accident. Wasn't really looking for them because I got enough power supplies back here. I got these big old linears. Yeah, sorry. I'm just getting over a bad cold. I was actually tested positive, been out of work for a week and trying to get over that. But I just wanted to come in here real quick. Felt a little bit better. And so I want to try to get this video out, okay? So what I want to do is I want to present these, and I also want to tell you how you might be able to find good deals on eBay, and maybe a little tip, okay? It's basically what to look for is the big tip. And you know, when it comes to power supplies, we know that Keysight is the new company. HP was the original. It was Hewlett-Packard, and then it became Agilent, and now it's Keysight. So you can find these older power supplies like I have back here at better prices. Although shipping is expensive because they're big old heavy linear power supplies, and they take a lot of room on the bench, and they're heavy and they're hard to move around. So once you got to think about how you want your bench set up, because it's no fun moving those things. These things weigh less than 10 pounds and 540 watts. That's another point. This is 60 volts, 9 amps. You can get both out at the same time. You got to be careful with that power supplies because a lot of power supplies say, oh, we have a power curve. They call it a 500 watt power supply, and they say you got 100 volts at 10 amps. And you're going, well, that's 1,000 watts. But anyway, you can't always get the voltage and the current. You have to stay underneath the wattage rating of the power supply as well. So they call that the power curve. So be careful of that. These things are rated at 540 watts. So it sounds like I can get all 60 volts, all 9 amps out. And that's what I want. So I bought one, and I was going to get it just to demonstrate it. It's brand name, low noise switcher power supply. But as soon as I bought the one, then the other one came up for sale. So I thought, ah, crap, I guess I'll buy both. Good thing was, good and bad, it's still expensive. I paid $500 for both these two things, but I've seen the price, you know, each is $250 up to $1,600 or more. I think they're around $1,800 new back in the day, and then like this one had a Xantrex name, and then they came out with a Sorensen name. They're bought by Sorensen, and now they're discontinued. So you'll probably see more of these hitting the market. These two units they're supposed to be new, so that's why I felt like I got a good price, because you can get refurbished ones all day long for $600, $800. And I'm like, holy cow, these are a good deal. And it seemed like too good of a deal. So I really looked into it, and I think the picture of it looked funny with this black thing on it. And I thought I knew what it was. Some people might have been afraid of the mods because there's no handle on top, there's no feet on the bottom, because they're putting a rack. And what that told me is they did something like this to set the voltage and current, and then lock them in place with something like this. So they had these made up, I guess. Or maybe this company made them, I doubt it, but who knows. But anyway, I thought, you know what, I think I know what the deal is. You just have to take this thing off. Sure enough, that's it. You got a couple screw marks in the plastic knobs, big deal. So they did that, plus they put a little tape over here on the side where you set the over voltage adjustment. Other than that, they're supposed to be new. They're not supposed to have been used, and actually, you know, they kind of have that smell like they're new, you know. I think when I turn them on, I'll be able to tell. Well, I actually turned them on already, so turn this one on. So I'm just going to finish up this video. I thought I could do that even though I'm still sick. So that's what I'm trying to do, is get a video out. And I wanted to present these because you'll see them on the bench. I'll be using them for some audio projects, because there's a lot of projects I want that are plus minus 45 volts or 50 volts. And I couldn't do it with these two, but I can with these two. And also brand name, low noise, spec. I thought it'd be an example of what you can actually get, you know. So the tip about how you can get these things at a lower price is just knowing the company, the brand name, so you know what you're getting. I believe this was a California company, U.S. made power supply. It was bought by Sorensen, which was another U.S. made power supply. And you guys been around for a while, you know Sorensens were great power supplies, just like these old HPs back here. And Sorensen was bought by Amatec, and so so you see some of those older Sorensens hitting the market. And then also Elgar was bought by Amatec, so you'll see those kind of power supplies. And what was the other one? California Instruments, and then a host of other companies they bought. But those were some of the big power supply companies they bought. And like this one, I think, you know, this guy is going to be a great power supply. It's also 10-turn pot, so it's fine-tuned. So I should be able to get some good resolution, low noise, and get the voltage I want to do some of these audio projects, and demonstrate to you guys what you can get with the switcher. So, and we'll take a look inside and see maybe, you know, how they did that. Now, one thing that's they note it as a soft switcher, so I don't know if, I don't remember if they pointed out whether it's zero current switching or zero voltage switching or both. Depending on where in the circuit, they might have both things happening, but it's supposed to be a low noise switcher, soft switcher, and that's one of the reasons they can get the low noise. The other thing is they have active power factor correction on the AC input, so the AC coming in is really clean. So yeah, these are supposed to be low noise power supplies, and that's what I wanted to demonstrate. So but yeah, those companies I named, if you can find those on the web, and I'll try to find these and put links. I'll put a link in my thing too, so you can maybe help some of you guys find some of these power supplies if you're interested. Alright, so let's just bring the camera over, and we'll show you this thing close up. Okay guys, here is the setup. I've got this new power supply. You can see it's a little thinner than the Kaiweets. It's a little deeper. Plus, minus input, and chassis ground input. And here's the volts set for 32, same as these. These are maxed out, so I just set this one to match these. And we're going to put a load on that's going to draw about 4 amps. But you can see the bar graph is pretty cool. And there'll be a bar graph on this side too. And the red light will come on if it overcurrents. So, pretty nice little setup. And I'm going to take the tape off this. I took the tape off the display, but yeah, let's take the tape off that too. And alright, so okay, so this is the bottom one is the modified power supply that I modified to lower the noise. That's where I'm connected up to right now, to the load. And I'm going to take these and I'm going to switch them to the non-modified and then to the new one, and we're going to look at the noise. And first we're going to look at the ripple. Okay, I've got the scope AC coupled, so we're just looking at the ripple. It's 50 millivolts per division, so we're zoomed in pretty tight. Okay, so what I'm going to do is, see right now you don't see any load, and then when I add the load you'll see about 4 amps, 3.97 amps, okay? And then I'll come up here, and from here you can see far back, but I'm going to zoom in on the scope so you can see it, and then I'll add the load. Okay, and then I'll come up here, and you can see how clean that is already, and then I'll add the load. And you can see how it doesn't really change even from back there. So you can kind of see what's going on even from back here. But I'll zoom in on this, and I'm going to repeat what I just did, okay? Alright, and let me just show you the load. It's right down here on the bench, and it's just an 8 ohm, pretty much non-inductive resistor. It's 200 watt, and I've got the resistor here, and I'll just touch it down here when I apply the load. Okay, so what I've got is the leads going to the power supplies, and I've got the scope going to the GW and SEC up there, and I've got a 1 microfarad cap. So I'm going to show you why I put that on there. I'm going to come up here and I'll show you each power supply with or without this 1 mic cap. We have some inductance in the leads, not much, but some resistance, and that just helps filter some of the noise right here at the load where we're looking at the scope. Now, because of these long ground probes on the scope and you know, and the setup, we don't get perfect ripple measurements. Usually you do it with the cap off, you do it on the board and stuff like that. But when you're doing setups like this, you know, real world type setup, you don't get ideal measurements as far as ripple. You get some high frequency stuff that are even made worse because of the setup, okay? And also remember, like when you're powering this to a real circuit, you're going to have input capacitors, filtering, and bypass caps and all that too. So a lot of the high frequency, if there's not a lot of energy in it, a lot of that stuff gets filtered in your product. Okay, so this is the Kai Wheats power supply that I've modified. It looks pretty clean. There's some spikes up here, you know, some high frequency spikes up here, but the actual ripple, or the most of the energy, is right down here. This is 50 millivolts per division. So I can go to 20 millivolts or 10 millivolts. Now you can see a little bit more. Now these spikes are kind of off the screen, so that's why I'm kind of coming out here, just so you can see the spiky stuff too. Okay, so there's the spiky stuff. We'll zoom in on that ripple in just a moment. But let me take off the capacitors just so you can see what happens. Okay, and that's without the capacitor. You just get a lot more spiky stuff, but the actual ripple is still pretty low. Okay, so I just want to show you that. Okay, now what we'll do is we'll zoom in. 10 millivolts per division. That's pretty tight. Now let's see if I can lock in on the... There we go. So that's kind of what it looks like. Alright, so I put some cursors up here, right here on that switching noise. See right here, this is switching noise. This is transistor turning on and off. This is just ripple on the capacitors. That's actually your lower frequency ripple, and this is high frequency noise. So I've got one cursor here, and it's about 32 kilohertz. Okay, so that's what it looks like. Now let me go ahead here, I'll get rid of that, and then let me go ahead and put the load on. Okay, I just applied the load, and it's a little bit more erratic, but the ripple's not really any worse. Let me zoom out, because sometimes you get a little bit more low frequency ripple, and we'll go back out here. Okay, that's 100 millivolts per division, but you can kind of see here. I'll freeze it. Anyway, you can kind of see there's a little bit of this stuff going on, but this is 100 millivolts per division, and this is a 32 volt output, so that's really not actually too bad. And like I said, this was 1 microfarad capacitor, but with a little bit more filtering on the board, a lot of this stuff won't even be able to be seen. But yeah, that's kind of what you get with a switcher that's not designed for low noise. Okay, so just turn it back on again. And now let's go to the new power supply. And there's the new one. That's what I mean by being a low noise power supply. Now we zoom in 10 millivolts per division, and you can see a little bit of stuff going on. And I'll freeze it. And here, let's get these cursors right in the middle of that cluster right there. About the same cluster. About 63 kilohertz between those. But yeah, so you can kind of see it's a lot lower noise. This is 10 millivolts per division, 32 volt output. So that is a pretty low noise switcher. I'll turn it back on and take off the load. Sometimes without a load it gets worse, but in this case, it's still pretty low noise. Now, I'll freeze it so you can see it. Yeah, so there you go. Fairly low noise. And that frequency's about 127 kilohertz between here and here. So, that's no load. Okay, I'll turn it back on. Now, let me take off that capacitor. Remember, that capacitor is still on for this one. So, that's without the capacitor. You get a little more high frequency noise going on. Let me freeze it. And here, let me even zoom out so we get 50 millivolts per division, so you can kind of see some spikes in here. So even with this low noise one, that 1 microfarad cap helps quite a bit, right? Now let me apply the load without the capacitor. That's without the capacitor. So see, it kind of cleans it up a little bit with even just having a load on it. Okay, there's the load. Let me just show you the power supply, what it looks like. Now you see the current, you see the bar graph. Pretty cool. I like that. Okay, now here, let me show you something. What we're going to do is go back here, and we're going to look at the spectrum on this, okay? Okay, so we've looked at the ripple. What I want to do is look at the spectrum now. If you had when you looked at the ripple, if you just saw a sine wave, say at, 200 kilohertz or something, you'd expect to see on the spectrum a spike at 200K. But when you see ripple that has a lot of noise on it, then the problem is with the switcher is that's generally what you see. And that means on the spectrum you're going to have content at different frequencies. So we like to look at the spectrum to see where that is. So let's come over and take a look. We're going to see what kind of noise is in the spectrum. So frequency and span, it starts at 1 hertz, ends at 10 megahertz. And amplitude 20 dBs per decade, okay? So we got 10 megahertz out here, so each one of these bars is 1 megahertz, okay? So we have 1 megahertz starting here, 2, 3, 4, so on. Now this is minus 40, so you see we have some noise just below minus 40 in the first 1 megahertz, maybe first 2 megahertz, and then it drops down to about, this is at 80 dB, so that's pretty low. That's a low noise power supply, so that is actually looking pretty darn good. And that's with the load. Now let me take off the load. That's without the load. Put the load back on, and now let me add the capacitor back on again. And here's with the capacitor, 1 mic cap, and here's without. So you can see across the band it does kind of help a little bit having a 1 mic cap on there. And see all that noise in that first bandwidth right here? You see all that drop? So that's with the capacitor. So the capacitor definitely helps. I'm going to go ahead and put the capacitor back on. And then what I'm going to do is take it out of that one, and I'm going to put it in the filtered Kaiweets. And look at that. The filtered Kaiweets pretty low. It actually looks pretty good. That's minus 60 dB. You see a little bit of noise there, but it actually looks pretty darn good. Then it has a hump here. So that's the improved Kaiweets, and that's with the load. And then I'll go to the unmodified Kaiweets. Okay, the unmodified, you see the noise up here at low frequency. You see a lot more noise down through here, and then it looks pretty good out here. So I'll go back to the modified Kaiweets. See, it cleaned up all this. Now let's go back to the new one, the Xantrex. And it looks pretty darn good. It's really low except for right here. So we're going to zoom in on this bandwidth to 1 megahertz, okay? Oh, by the way, the bandwidth 5,000. I mean, the bandwidth is looking really good. Let me show you. It's 2 kilohertz. The resolution bandwidth at 10 megahertz. That's pretty darn good. We're going to go frequency and span and stop at 1 megahertz. Okay. Now the center frequency is almost 500 kilohertz right here. 1 megahertz is over here. Okay. Now here, let's go back. Let's go start. 1 hertz. Okay. So now the center frequency is 500K, 1 hertz, 1 meg. There we go. Okay. Now you can see now we got, this is that noisy thing that was down inside the 1 megahertz. It kind of extended past 1 megahertz a bit. Most of it was right here. So that's the clean power supply. Now let me take it out. Now look, that's what we call the noise floor. That's just ambient noise floor of our test situation. It's right down here at minus 100, and there's something going on right there. Let me get rid of the cursors. And this green arrow is right here, meaning the minus 46 dB. Right in here, there's an orange spike right in there. And that's happening at 1 hertz. Basically DC. Okay, so now I'm going to put it into the modified Kaiweets. It looks pretty darn good, right? There's a modified Kaiweets. Now let's go to the unmodified Kaiweets. That's the unmodified Kaiweets. So minus 40. Now remember, 0 is 1 volt, minus 20 is 100 millivolts, and that is 10 millivolts. So minus 40 is 10 millivolts, and there's a spike right there, and the rest of these are below that. So it's still actually relatively low noise, but that's the non-modified Kaiweets, modified Kaiweets, and here's the new one. So not too bad. Alright, so I just want to show you something. What I'm going to do is I'm going to zoom in on the screen so you can see better, but I'm going to first show you zoomed out so you can kind of see what I'm doing. What I'm going to do is take the leads out, and I'm going to first start with the negative one. I'm just going to touch the negative, the positive, and what you'll see is they look the same. And I'll touch ground, they'll look a little different because that's common mode noise. The noise is between plus ground or chassis minus input and chassis. Okay, so I'll do it again, and I'll touch each one, and then I'll touch a plus. You'll see that, and then I'll do it to each one. Okay, so I'll go here, minus, and now the ground. Then I'll go to plus here on the modified, and the minus on the modified, and the chassis on the modified. Okay, I'm going to do that each one, and then I'll do the negative lead on each one, and then I'll do the positive lead on each one, so you can see it close up. Okay, I'm going to start with the modified Kaiweet. The negative lead I'm putting in the red terminal, and you can see that little spike right there. It's a tall spike. This is 100 kilohertz, so it's like 30 kilohertz or something. Okay, so then I'll go into the negative terminal, and you see same thing. Now I'll go to chassis. It's so different, right? Okay, now I'm going to take the plus lead and put it in the plus terminal. Okay, so the plus one's a little bit taller, and this time the green arrow picked it out, and it's saying minus 34. So it is a little bit different. Okay, I'm going to take the plus into the negative terminal, and that looks the same. Okay, now put the plus into the chassis. Okay, now I'm going to the non-modified Kaiweets, the black probe into the red terminal. Okay, now the black probe into the negative terminal, and they look the same, and then now into the chassis terminal, and it looks different. It's cleaner, not much filtering going to the chassis. Okay, now put the red in the red terminal. Okay, now put the red into the negative terminal, and now put it into the chassis terminal. Alright, so now I'll put the negative into the new power supply in the negative terminal. Now I'll put the black one in the red terminal. See, they look the same. And now I'll put it into the chassis. Okay, now I'm going to take the red lead and put it into the negative. And then I'll put it in the plus. They look the same, it's common mode noise. And then I'll put it into the chassis, and that looks different. So that's pretty interesting, right? And again, that's just because it's like having a noise source going from plus to chassis to negative to chassis. So when you look at either one of these, that noise gets on the lead, and that's what we're seeing. It doesn't even matter if the load's connected with both leads or not. So again, just so you can see it close up there. And then I'll put this one. So then I'll just go ahead and connect this. And there's our load, and looks the same, right? Looks the same with or without, right? And then I'll take this out, and there's our noise floor. Alright guys, so I hope that was interesting to look at the ripple and then also look at the spectrum. Now let's open this thing up and see what it looks like inside. See how it compares to, say, a Kaiweets. And that link would be down below where I reviewed the Kaiweets. And I did two. One where I reviewed it and then one where I improved it, you know, where see the before and after noise thing, okay? And in a future video, I'm going to come up with a little filter block that you can use for any switcher to go between the output to your product to just help clean things up, okay? Meanwhile, let's jump inside this thing. Okay, so for a quick look in, we've taken the connectors off the input, the power cable off the output. It looks like there's 2, 4, 6 screws, and I'm assuming this back end will slide out because that's the way it kind of looks. And I got the bar on this one. This is the second one. And incidentally, this was powered on at 42.5 volts, so that was interesting. That's where it was locked in. Okay, this is the sense leads right here. And that's the remote output. This is a programming connector. And the power in connector, of course, and the fan inlet. So it looks like it just slides on out the back end, the cover here. So let's take it off. Alright, I removed the 6 screws, and sure enough, it feels like it's going to slide. Well, hold on a sec. It feels kind of snagging on something. Oh, I think it's just the faceplate up here. Alright, if you ever have one of these, what you have to do is pull up to pull the slot from the front cover from between the board and this. That was kind of tricky. Now, we should be able to slide this off. Wow, not as simple as I thought it would be. The front is connected to the switch all the way coming up here to the input power section where the power comes in. I can see a choke down in here. So yeah, it looks like the EMI section's right up here, and then the power comes off this and comes up here to the other board. And here's a green wire connecting that board's ground to the chassis. And then here, the green wire will come right down to the chassis. I can see it connected right down there. Then there's our input with our nice 10-turn pot, some film capacitors, tantalum capacitors. And on the other side, we have our other 10-turn pot. And then we have what some of us call fish paper. This looks like a kind of a different style, but it's just meant to be insulative paper. Kind of a, you know, it's just easily wrapped over and screwed down there in that one spot. And then down here, it kind of is cut so it drops in the screw right here. The standoff drops, captures it here, and it's probably captured down here on this this screw. Alright, removed the screw here, and it just reveals this big board, but man, this thing is a bear to remove or to dismantle. You can see all the different boards. It looks like to get this board out, I have to remove connectors. Looks like I have to do all kinds of things just to take it apart. Holy smokes. Okay guys, this has proved to be a real pain to get out. I've had to disconnect all kinds of things. And as I tried to lift this up, the front display is connected to this card. As I try to lift it up, it's connected down here with this connector, which I pulled that off. So you are seeing the boards same time I'm seeing it. So, wow. A lot of through-hole parts up here. I'm going to rotate it around so you can see it. Wow, that is pretty crazy. Looks pretty old school to me. Let me get a better position here on the camera. Alright, so let me see if I can zoom in on this. Alright, so the connector I removed is right down here out of screen. Connect right here, so that was input power to this. Looks like a flyback converter. And probably a bunch of voltage regulators on the output. We got some transistors here. and LM337 negative voltage regulator, some LEDs for probably troubleshooting, and here's a LM317 for the positive voltage regulation, and a nice filtered connector here for these sense pins. These are the sense pins. That looks like comm mode choke went out to them, and probably some diode protection, I'm assuming, and a whole bunch of chips. LF347 op amp here, analog device op amp, another analog device op amp, OP77s. So yeah, just a whole bunch of stuff. Here's a crystal. This is what we call a housekeeping power supply, just to, you know, keep everything running. Alright, so that is a control card for all the programming and signal processing and all that stuff. And I removed 3 screws here for this FR4 board used for insulation between this low voltage card and the power supply. See if I can. No, there's something else. Oh, there it goes. It's clipped on right here. There we go. Whew, that was a lot of work. Okay guys, it looks like the input power comes in, the MOVs here, a poly cap, a bridge rectifier on this piece of metal here for heat sinking, the poly cap here, and the relay here, and there's a thermistor down there. So here's the big power chokes, and the input, this is for the PFC stage. Here's a volt capacitor for that stage, and then it wraps around and looks like it comes through here for our LLC stage. So this is our LLC, looks like it might be a full bridge, four transistors. That's probably the resonant capacitor and the transformer and resonant inductor, I'm assuming. And then the output stage here, I think, is what we're seeing. Now, by the way, you see these thermistors on each heat sink. There's another one on this heat sink, so you'll have thermal cutoff. Here's the fan right here blowing down these heat sinks. It blows through this channel and out there, I suppose. I don't know if it's blowing or sucking, but the cooling channel is right here. And then here's our output section. A comm mode choke, bunch of capacitors. So a lot of filtering to our output, and then our output wires come back up here through some ferrite, through these chokes here to the output connectors where there's some more capacitors down on this board. See if I can turn that so you can see it. I'll turn that so you can see it a little bit better, but yeah, so our capacitors here for the final stage. So pretty crazy. Oh, and by the way, it fused down here too. It's probably for the between the stage of the PFC stage and the LLC stage, I'm assuming. And I see another heatsink over here and some parts mounted to it, and the ribbon going to the top. So some more voltage regulators possibly, or something for output stage to back to this board. And finally, another thing, you see these trim pots up here, probably for the display, for the current and the voltage outputs. So yeah, this is a pretty complex power supply. There's a couple of details I want to point out. This little shielding band, a ghost band or whatever it's referred to, wrapped around this transformer, that's pretty nice. Attention to detail for EMI noise. Now also this little plastic, the way it connects into here, the neat thing about that is that it forces the board down there to stay up off of this by that spacing right there. And plus you see the fish paper underneath that board. So there's no way, you know, so there's lots of insulation between, you know, there's spacing plus the insulation paper between that power board and the bottom here. And finally, this piece of plastic has this metal insert to stand on top of that to push this fan down. See, the fan's just kind of sitting there in a slot in the board. There's a cutout in the board that's sitting in, and this just comes down. So it's metal and plastic. I'm just going to put a piece of tape just to dampen any vibration noise that possibly could have been happening. I don't know if there was, but that's a pretty nice touch how they did that. Then it's screwed in right here to hold that there, and screwed in right here, so it's held in these two places across this. Alright, and then up here it's holding this board in place too. So it's locked in on both sides, keeps this thing locked in. It's screwed in here, but it locks these boards in place too. Nice setup. Alright guys, so what do you think? These are efficient power supplies. They're about 85%. And, you know, right off the bat you might go 85% doesn't sound that great for a switcher. But now you got to remember it's AC to DC. So that active power factor correction, that boost circuit in front, it's going to be let's say it's 90 something percent, 95 let's say. And then the DC to DC, the LLC converter after that, which I'm assuming is what this has, then that thing, let's say if it's around 90%, well, you multiply both those together and you're right around 85%. So that's why you got two stages of conversion, and they're both efficient, but together 85%. That's still pretty darn good compared to, like, let's say these linears back here. The other thing is, because it's active power factor correction, let's say the 540 watts at 85% is, I think, 635 watts. So you got 635 watts coming in. So since they're about 0.98% power factor correction, that means the voltage and current peaks are almost lined up, almost unity. Unity would be if it was 100%. Well, the linears back here are going to be a lot worse than that. And as a matter of fact, this Riden up here that I reviewed one time, I built that out of a kit, right? And part of the kit was a power supply that I bought separately to put in it. Well, the power supply I bought in it does not have active power factor correction. This Riden actually almost will put out almost as much voltage as this. So, and it puts out almost double the current. So, and this one has a whole lot more controls. This is actually a better deal, I think. The problem with this, if I were buying something for my bench, I'd go with this. And I'll put the link to my video down below for that one. Here's the problem I'm running into. Maybe you guys have already solved that problem. But this one, number one, fan noise. So it's pretty loud to do videos with those fans, because that's a pretty powerful fan in that one. Okay, I could solve that problem, I think. The other thing I have is the power supply I bought with that. I want one that puts out, say, 60 plus volts, so I can get close to 60 volts out, because it's a buck converter inside there. But it also has to put out 18, 20 amps, because I want 18 amps out of that. But here's the trick. I want one with active power factor correction with LLC converter on the second stage. A lot like the way I think this is designed. So if I had that, then this would be pretty much a perfect bench supply, I think. And I think it was low noise too. Depending on that power supply, it'll be even lower noise. So because it doesn't have active power factor correction, it's probably a little noisier than it needs to be. But it was actually not bad. So yeah, take a look at that video. I'm going to search to find a power supply for that. Once I do, I'll buy another one, so I'll have a pair of them. And that means these, I kind of jumped on it because they're low noise. But now that I go back and think about the ride-in, focusing on that, getting the right power supply in that, I think that might be the better route to go. At the time I was just going to buy one of these. I ended up buying two and put a lot of money into them. And I think I could probably get that money back out, maybe a little bit more. And so maybe I'll do that and move on to these. But meanwhile, I'll use this for my next audio video so I can power an audio amplifier with it. Okay, so stay tuned for that. Hey, thumbs up if you like the video. Really appreciate that. Free way to help the channel. It does make a difference, and I do appreciate that. And oh, and become a patron if you like, for a little $1 a month. They're linked down below. And I'll have a link for the Kaiweets power supplies if you like those. These guys, for up to 10 amps, 30 something volts, 31, 32 volts, they're great power supplies. I love the wattage meter on them. The Riden has that as well. So really, if you got two Ridens, that's all you really need, I think, for audio work and for a lot of work. But and if you don't care about fan noise, then you can do the same kit that I got. So yeah, again, I'll put the links down below, okay? Thanks for watching, guys, and again, thumbs up. See you next time.